Hello and welcome to STAT 441 at Virginia Commonwealth University. In this lecture, we will learn how to conduct a hypothesis test for the population mean. So in the previous lectures, we discussed how a hypothesis test or a statistical test can be conducting. These are the 5 steps that we will use for conducting the test. And then in this lecture, we are looking at the parameter population mean, mu. The first step will be to state the null hypothesis about one or more population parameters. So it could be just the mean or difference of the mean or proportion or difference of proportion. And then we state the alternative hypothesis, HA. This is what we are trying to test. It would be with the less than, greater than, or not equal sign, depending on what we are trying to test. Then step 3, we calculate the test statistic, which is computed based on the sample data that we have collected. And we discussed the rejection region method, which is a classical method, and the p-value methods. We will use the p-value method here to conduct the test. And then finally, the conclusion will be written, and the decision is based on whether to accept or reject the null hypothesis. We will reject the null hypothesis if the p-value that we have calculated in step 4 is less than alpha. Now this alpha is called the significance level, which is chosen at the beginning of the test. And it is basically the probability of making a type 1 error. Usually small numbers are chosen, such as 0.1, 0.05, and 0.01. And if nothing is stated, usually 0.05 is the standard to use. So here is the first set of information for conducting a hypothesis test for population mean mu. And this is the case when we have a large sample n greater than equal to 30. So here let's see what the hypothesis will look like. So it could be a one-tail or a two-tail test. For the one-tail test, H0 will be mu equals mu0. That's the value we're testing against. And HA could be a greater than or a less than sign. And then mu0 is again the same number. If it's a two-tailed test, we have not equal sign in the alternative hypothesis. Here is your test statistic that we will use. Y bar minus mu0 divided by S over square root of n, where mu0 is the number in the hypothesis, Y bar is the sample mean, S is the sample standard deviation, and n is the sample size. And same test statistic for a two-tailed test. Now, if we were using the rejection region, we discussed that earlier. The rejection region would be a normal distribution, and then depending on our choice of alpha, we will either mark the right hand side of the distribution or the left side of the distribution. Let's say we have chosen an alpha of 0.05, then basically the rejection region is the top 5% area of the distribution for a greater than test. If it's a two-sided test, then our rejection region is on both sides of the distribution, on both tails. So basically, if our alpha is 0.05, then 0.0 to 5 on each side of the distribution is the rejection region. But the p-value region does not need the identification of this rejection region. We can straight away calculate the p-value depending on the sign in HA. So if it's a greater than test, p-value is probability of z greater than z calculated. That's this value here. If it's a less than test, p-value will be probability of z less than z calculated. And if it's a two-sided test, p-value will be 2 times probability of z greater than absolute value of z calculated. And this is simply calculating the probability, just like we did for the normal distribution using the standard normal table. So here the assumptions, what we have in the hypothesis. Mu0 is the symbol for the numerical value that will be specified in our hypothesis. ZC is the computed test statistic. And the assumptions in this case are none, because we have a large sample size and we are applying the central limit theorem. Here's the first example. Large sample test of mean of length or length to width ratio of bones. And this is denoted by mu. This slide is showing it incorrectly. When fossils of humerus bones are discovered, archaeologists can often determine the species of animal by examining the length to width ratios of the bones. It is known that species A has a mean ratio of 8.5. Suppose 41 fossils of humerus bones were unearthed at an archaeological site in East Africa, where species A is believed to have inhabited. Assume that the unearthed bones are all from the same unknown species. The length to width ratio of the bones are measured and are listed. Okay, so this is our data set. These are the values that are collected in the data. Now we wish to test the hypothesis that mu, the population mean ratio of all bones to this particular species, is equal to 8.5 against the alternative that it is different from 8.5. That is, we wish to test whether the unearthed bones are from species A using a significance level of 0.01. Okay, so we are trying to test if this is different from 8.5. So let's start by stating the null and alternative hypothesis. H0 will be mu equals 8.5 and HA will be mu not equal 8.5. Remember, we just wanted to see if it was different than 8.5. We're not interested in a specific direction, less than or greater than. So we will use a two-tailed test. The sample size here is large. We have a sample size of 41, so we can proceed using a large sample test. Okay, so from the sample, we can figure out the mean of the sample, which is y bar 9.257, and the standard deviation of that sample is 1.203. That means our test statistic is y bar minus mu 0 divided by s over square root of n. 8.5 is the number from the hypothesis. This is the sample mean, standard deviation, and 41 is n. So 4.03 is the test statistic value. Okay. Now, if we were using the rejection region, just to understand what it looks like on the graph, this is what it would look like. Our significance level is 0.01. Okay, alpha is 0.01. Therefore, on each side, we have to use alpha by 2 area, which is 0.005. So 0.005 on this side and 0.005 on this side. So if our observed value falls in this region, okay, either one, then we will reject the null hypothesis. Okay, now this corresponds to a z value of 2.58 and negative 2.58. So if our z value, the observed, is more than 2.58 or less than 2.58, we will reject the null. Well, in this case, the z value is 4.03, which falls in the rejection region. So we will reject the null hypothesis. Let's see what the p-value does for us. So it's a two-sided test. The p-value will be 2 times probability of z greater than z calculated, which is 2 times probability of z greater than 4.03. Okay, if you use the z distribution table at 4.03, the probability is approximately 0. So this, we can use this value, and 0.5 minus this value. Okay, that's really, really small. So we can say that the probability is approximately 0. Okay. Now, since the p-value is really small, we compare it with the test. We compare it with the alpha value to make our decision. So here, the p-value is less than 0.01, or alpha is greater than the p-value. Therefore, we will reject H0 and conclude that the mean length to width ratio of all humerus bones of this particular species is significantly different from 8.5. Okay, now we can conduct the same test, but let's say we do not have a large enough sample and we have a small sample. So how can we still conduct the test? So here is what the change will be. The way we write the null and the alternative hypothesis, it's still the same. We have mu equals mu 0 and then greater than, less than, or not equal sign in the HA. Test statistic will be y bar minus mu 0 over S divided by square root of n. So the only change here is basically instead of a z, we will use the t distribution. Rejection region will be similar. It would be either on the right hand side, left hand side, or both sides, but we will use the p-value method. P-value for the test statistic still will be calculated in the same manner. It will be the probability of t greater than t calculated for a greater than test, probability of t less than t calculated for a less than test, and 2 times probability of t greater than absolute value of t calculated for a two-sided test. Okay, so let's look at an example. The federal government has the maximum allowable level of benzene in the workplace from 10 parts per million to 1 parts per million. Suppose a steel manufacturing plant which exposes its workers to benzene daily is under investigation. 20 air samples collected over a period of 1 month and examined for benzene content yielded the following data. It's in the table on the next slide. Is the steel manufacturing plant in violation of the new government standard? Test the hypothesis that the mean level of benzene at the steel manufacturing plant is greater than 1 parts per million. Use alpha of 0.05. Okay, so let's say these are the values that were observed for the sample. As you can see, it's a small sample, less than 30. So we will use the t distribution. So step 1 will be to list the H0 and HA. So here we want to test to see if the mean level of benzene at the steel manufacturing plant is more than 1 ppm. Okay, so H0 mu equals 1 versus HA mu greater than 1. It is a one-tail test. Okay, here's the test statistic that we will use. T is equal y bar minus mu 0 over S divided by square root of n. The assumptions here will be that the population of the benzene levels for all air samples at the steel manufacturing plant are normally distributed. Okay, now here again, if you were to use the rejection region approach, this is what it would look like. Our rejection region would be on the right hand side, alpha is 0.05. So this top 5% of the area, which corresponds to a T of 1.729 with degrees of freedom 19. So if the calculated value is above 1.729, then we will reject the null. If it's less than 1.729, we will fail to reject the null. Okay, so let's calculate the test statistic. Test statistic is 2.143, that's the sample mean, minus 1, which is the number from our hypothesis, divided by S, which is 1.736 over square root of 20. So 2.95 is our test statistic value. Now we can calculate the p-value for this by using the t-table. Probability of t greater than 2.95 with degrees of freedom 90. So if we can find that value from the table. So we will have to look for degrees of freedom 19, okay, and 2.95 is what we are looking for. Degrees of freedom 19, 2.95 is here. It's actually more than this number. So what we can say about this p-value is that the p-value is less than 0.005. So it's really small. Okay, now compare it with alpha. So alpha is 0.05. It exceeds the p-value. So we will reject the null hypothesis. Therefore, the OSHA concludes that mu is greater than 1 parts per million and the plant is in violation of new government standards. So here is hypothesis test for one population mean. We looked at two cases. where we have a large sample versus where we do not have a large sample. Thanks for watching.